Recording. Okay, for D. Sorry, I'm doing it wrong. Okay, just hold on. Let me just fix this here quickly. I kind of heard what you said, but I didn't really. Sorry, because my attention was split. Okay, so that would be the first part. And then when it is wider, it's going to fill up more slowly. Sorry, Nicholas, say again.
So what I did is I started on power and on the ball, and then I kind of went.
So you did a shallow and then a steep. So if we look back at the beakers, right? Yeah, but even so, if we look back at the beakers, then it would be that kind of situation where it starts off shallow and then it becomes steeper. So I hear what you're saying, but you are going to have to fix that, because here, even if you pour the water in from this side, the wider part isn't going to fill up first. It's going to run into that part. All right. As soon as the water reaches that edge, it's going to go into the narrow part. All right. Okay, guys, are we fine on that one?
Yeah.
What about E? What's happening in E? Yes.
So I thought if it was being filled from the deepest point,
Yep.
it would kind of have like a gradient, like.
Okay, so it would have a gradual, it would be a curve. All right. Okay, so let's quickly think, guys. Here, the point, basically, because this is kind of like a point, right? Where it starts filling up first. Do we see that it's starting obviously very narrow and then it's getting wider over time, right? So the increase is going to be quick and then it's going to become slower over time. Does anyone remember how we draw that? If it's fast at first and then slower, right? So it has a big increase and then it almost like goes flat. So this kind of thing. Yes, exactly. So it starts off fast and then it becomes slower gradually. Okay, so we use a curve for that.
But doesn't the end it just goes normal?
What do you mean?
I think that's a lot.
Oh, yes, that's true. Okay, so if we're taking from here where it now becomes just going straight up. Yes, sorry, I didn't even think of that. So guys, for a bit, it is like that, hey, up until it gets to that point. Then as soon as it gets to that point, now it's straight. So now we have to show a straight line. All right, and it's just going to increase. The water level is going to increase kind of at a constant rate. So yes, thank you, Finn. We do have to have like a straight line coming off of there. Oh, I didn't really leave myself enough space, but we'll just do that. So you can just draw a straight line kind of at the end of your curve. Does that make sense, guys? Because for that last bit, it was a straight edged part, the pool. Okay, let's look at A and B. A, what's happening there? It starts off narrow and then it increases gradually, right, for a little bit, and then it's wider and then it will increase gradually. So how do we think we're going to draw that? How will we draw that first part? What do you guys think for that first part? Yes. Oh, I thought your hand was going up, but yes. For this first part, it's the same as for E, right? For part of E. So for the first bit, it's going to, because it's starting off narrow, it's not quite as narrow as here, but that's fine. Starting off narrow and it's increasing gradually, so we can use the same shape. And then what's going to happen here? Straight edges, so we're going to use a straight line. So it's almost the same as E, all right? Now, guys, how are we going to indicate that there is a difference between A and E?
So you make the curved line shorter, and you make the line on E, the straight line longer.
Straight line longer. Okay, we can try that. Guys, let's look at how it starts. What's the difference between graph A, how it starts, pool A, how it starts, and pool E, how that one starts? Just want to give everyone a chance to think a bit. Right, just look at these two. Natalie?
A is flat and E is
Yeah, so A is flat. A has a flat part there at the beginning, and E has a pointy part at the beginning. How will that influence the graphs? Joseph, you want to try?
So I think that because E starts off with like a curve,
Mhm.
it, I think A would start perhaps maybe as like a line, either a line, or it would go curve under instead of curve through.
Okay, so let's talk about the curved under. Remember when we curve under, we're saying that we have a gradual, a slow increase at the beginning. Could that possibly work? Let's just think here, guys. If we're filling up this pool, what's going to happen at the beginning? Is it going to have a sharp increase? Because for E, because it's just kind of like that point, it's going to increase very quickly right at the beginning. Okay, what about here? Cameron, do you want to try?
It won't increase as much because it's more surface area on the water for it to go up high, not just the.
It's not just the point. So it will increase, all right? Well, the depth of the water will increase, obviously, but more gradual than in the case of E, right? Because at first, with E, we literally put, I don't know, a little bit in and it's gonna shoot up quite quickly. For A, because we have more surface area, like Cameron is saying there, it's going to start filling up more slowly than E. So guys, if we're looking at E, right, the way that I've drawn it, and this is kind of a rough sketch, it's not particularly perfect necessarily, but do we see that we have a sharp increase right at the beginning? Now, how can I indicate that in A, we have a slower increase? What do you guys think? Cameron?
Maybe you could like
Okay.
have a lower angle, like 45 degrees.
I can decrease the angle, right? If we look at this, it's a very sharp increase right at the beginning. For this one, it's going to be a more gradual increase, all right? So maybe kind of a lower curve in a sense. And then what happens where we have the straight edges? We're going to have a straight line. Okay, so let's try that. And again, guys, these are rough graphs, so don't worry if it's not exactly the same as mine. But we do have to be able to tell that there is a difference between pool A and pool E. Okay, we can't have the same exact graph for the two because they are different. Right, let's look at pool B, the last one. We're nearly done with these questions. Pool B. Do we notice that the first part of pool A is the same as pool B? Right, so we can just copy that bit, which was almost like a slow, like quite a flat curve. And then what happens for the second part of pool B?
Flatter curve,
A flatter curve. Why flatter now?
because there's more surface.
Because it's wider than the first part, right? So the first part is going to be flatter than E at least, all right? But it's still quite narrow, okay? Getting slower because it's widening as we're going up, and then here it becomes even wider. So now, guys, when we are drawing our two curves, they can't look the same, okay? They are going to have curves, but the curve for the bottom part, the first part of pool B, has to be at a higher angle than for the second part. Okay, let's see if I can try and draw that. Okay, so let's do that for the first part, and then for the second part, I don't really know if that is a bit flatter, hey, the second part there. So see if you can do that, guys. So you see my first curve is kind of going up to the first line, and then the second one is at a flatter angle because it is wider, so it will fill up more slowly. Yes, Cameron?
The depth is the same as the first part, so wouldn't it be like, it would reach the second line and it would just go on for long.
Yeah, so I could if I just carried it, if I just drew it for long. Yes, you could make it reach the same depth, yeah. I just don't have space. Okay, guys. I don't want you to worry about these graphs. I don't think you'll get something like this in a test or exam, maybe as like a problem solving question, but I know that some of the classes didn't even do these worksheets. So yeah, at least now we have discussed, you know, how to think of rates in which something is increasing and how to show that on a graph. All right. So don't panic and don't think, oh, you have to know exactly how to draw pool B because this exact question will be in your test. It's not the case. All right. Those speed, distance, time ones, some of them were a bit confusing in the sense that it almost looked like you would get a negative answer for some of them, right? But guys, remember that speed can't ever be negative. So if we're looking at, I think it was 4, 5, and 6. Let me just double check that quickly. Sorry, it's all stapled together here. So 1, 2, 3, these ones are simple, all right? You just take the distance like we did in class yesterday. So 3 kilometers in 2 hours. So 3/2 kilometers per hour. For this one, I'll show you all the answers now. It was 2 kilometers over 4 hours. So 2/4, which is a half, right? I'll show you that now. Same thing for that one. But guys, if we're looking at these ones, what is the distance that was traveled in the 2 hours? If we went from 4 to 0, how many kilometers did we cover? It's still 4, right? Even though it's 4 kilometers going down, I suppose. So we could almost say that this was the distance from home graph, in a sense, where this is home, here you're traveling away from home. But you're traveling for 3 kilometers in 2 hours. Yeah, you're traveling from school maybe to home. It's still 4 kilometers in 2 hours. All right, so your speed will still be 4/2. The fact that your line is going down is not going to now make your speed negative. How can you have a negative speed? How will that work? Okay, so I don't want you guys to think that because the line is going down, now you need to change the sign. You're still reading off how many kilometers you're traveling in how many hours. Okay, so all of those answers were still positive. So you can just take a look there. That's 1 to 4 on this side. You just had to use the same formula for all of them. It was distance over time. And guys, something like 2/4, you can't leave it as 2/4. All right, you have to simplify that either to a half or to 0,5. But 2/4 is not the simplest form, so you can't leave it like that. And with number 3, 4/2, you also can't leave it like that. Okay, 4 divided by 2 is 2, so you do have to simplify it. For the first one, because it was 3/2, we can't actually simplify that fraction. So you could leave it like that. You can just write it in a different way if you prefer. So you can write it as 1.5, but that's not necessarily simplified. Okay, 3/2 is fine. There was a number 9, which is down at the bottom. I'll show that to you now. Just let me know if you have any questions on any of these. Okay, number 9 is down there. So it was 12 kilometers in 8 hours. So now again, that's a fraction that you have to simplify. 12/8 is the same as 3/2, right? Because 4 can go into 12 and into 8. And if you divide each of those numbers by 4, you get 3/2, which again, you're more than welcome to write 1.5 or 1.5 kilometers per hour. It's up to you. Any questions? All right, guys, I'll leave that up. I'm going to hand out the new worksheets. There are 2 worksheets. I'm not sure how long it will take you, but it is basically an application of coordinates.
There's actually my sister's lunchbox.
It's a lovely lunchbox. I like
And
it.
it's good, it's good. But,
Yeah. Think, anyone made by person? Person was at the call from- Where to go?
sorry. Oh, yeah.
Calling ordinance. Councillor Whittaker. Okay, guys, look at that first worksheet. You can start working on it now while I hand out the next one. So they're saying, you don't write on the sheet, you can't write on the sheet, it's your own one, I don't know what it is. Type of thing. Listed below are some of the worst strokes ever told. Find out what they are. So each coordinate, they each say a coordinate represents a specific letter. So let me help you with the first one, 4, 3. Guys, what order do we use for these orders? Always X first, then Y. So if we say 4, 3, you're going to go to 4 on the X axis, which is the horizontal one. And 3 on the Y axis. What letter is in line with 4 and 3? W. So the first letter of that joke is W. Right? You're going to find all of those letters. Well, the first one has 4 letters, so it didn't come with a Y.
It can be a what?
It could be a what? But I don't spoil the file. Alright? Have a little chuckle, hopefully it will make you laugh. I don't know what these jokes are either, I haven't done this yet. And you are, yeah, I was supposed to do all of them, alright? And by the end of this, you will never ever again be uncertain about how to read all coordinates. Okay, I'm handing out the second worksheet, which you might not into, but we'll see. If you finish that first one, you can do the next one.
Oh, no, at the end of the worksheet. I wasn't good.
We'll see how it goes on the side. Yeah, but I think the second one up.